chemical energy, okay? So there are two types of reaction, endothermic and exothermic. Don't copy anything first. I'll give you time to copy one. After I let you copy, you have to memorize it. Before you step out from this class, you have to memorize it, huh? Okay, now, so the triangle H, it means heat of reaction. If it's a positive, then I know it's an endothermic reaction. Okay? So Jeremy, you tell me, if let's say I have something like this, positive 7 kilojoule per mole. This is exo or endo, and why? It's an endothermic reaction because it's a positive. Do you understand what I'm talking? Kilojoule per mole means 1 mole of the substance. MOL -1, short form for MOLE. Okay, so it's like per kg like that. This per mole. Kg -1. I'm saying just similar to per kg. Kilojoule. Kilo is times 10 to the power -3, times 10 to the 3. Yeah, 1000. How many zeros are there? So it's 1 times 10 to the power 3. Yeah. Okay, now, yes, you are very good. Okay, very alert. This heat of reaction, the unit is always in kilojoule per mole. Definitely one. Kilojoule. Come again. This. Yeah. Okay, now next one. So like what I say, endothermic, there are 5 things that you need to know. 1, heat is absorbed. I'll tell you why they're like that. You just memorize blindly first. Okay, 2, 3, 4. The 4th one is the heat content of reactant is lower than heat content of product. Okay, and then your graph, it looks like this. Tell me what about the exothermic? You just go opposite of each I write in endothermic. So heat is absorbed in endothermic. So what about exo? Yeah, it's released. Surrounding temperature. Yes. Now the surrounding temperature, the one that I meant here, sometimes it can be the cup they are holding the solution. Yeah. So the surrounding here, it might be the container. Not necessarily must be the surrounding, okay? So heat is released for exothermic reaction, and the thing become hot or the surrounding temperature increases, and heat of reaction is negative. Okay, and heat content of reactant. Yes, very good. Actually, you can look at the graph. Since I did say it's higher. So energy diagram, your y-axis, you have to label energy. So reactant heat level is higher. So this is your energy diagram. Okay? When you draw an energy diagram, you have to label your heat of reaction is a negative value, and the unit must be kilojoule per mole. Okay, heat content of reactant is higher than heat content of product. Very easy, right? So there's a lot of reaction. I did summarize for you. IGCSE, you just memorize 8 endothermic reaction. Other than these 8, everything put in exo. Okay, I will list out the 8 reaction. Again, endothermic 是 absorb heat 还是 release heat Jeremy? What are the 5 things that I asked you to memorize? Let's go back to the thing that I write just now. Heat is being absorbed, surrounding temperature decreases cooler. Now, a lot of students, they confuse. They ask me, teacher, heat is being absorbed. I thought the thing should be very hot. Now, heat is absorbed to do something, to overcome the bond between the particles. It's not to increase the temperature. So you don't confuse about that. Okay, I repeat once again. A lot of people, they keep on asking me, teacher, I thought heat is being absorbed, the thing should become hot. Why is something become cold? Because the heat is being absorbed to do something else, which is to overcome the bond that hold the particles together. Okay, so what you need to know is when breaking bonds, you absorb heat. Forming new bonds, they release heat. Why is it there's exothermic reaction and endothermic reaction? Because there's a difference between the energy being absorbed during the breaking bond and absorb heat. Forming bond, release heat. There are some bond, yes. Forming new formation, they release heat. There are some bond, it's very strong. They need to release a lot of heat in order to stabilize. Okay, you learn how to calculate in A level. Okay, now, so endothermic is heat is being absorbed, the thing become cooler, or colder. Okay, now, so as I told you, so from my experience, I already sum up, there's only 8 endothermic reactions. Other than these 8, please categorize them in exothermic reaction. Now, example of endothermic reactions are melting, evaporation, or boiling. Now, because you see, during melting point, your particles is moving away from each other. So in order for the particles to move away from each other, they need to absorb heat to overcome the bonds that hold them together in solid form, right? Same thing explained during evaporation or boiling process. Yeah. So other than these two, photosynthesis is a kind of endothermic as well. Like during hot day, normally you like to stand below a tree because it's cooler. Okay. Now, other than that, dissolving ammonium salt. Meaning, for example, if the question say putting ammonium in the water, then you know definitely is a endothermic reaction. Okay, another one is dissolving crystalline salt. Or hydrated salt, okay? You have to memorize this 8. Better. In order for you to score A+. Yeah. Crystallized salt or hydrated salt. I can memorize. You, same to you, okay? Your brain are very fresh, so you can do better than me. Reaction between acid and bicarbonate or hydrogen carbonate. This is different from metal carbonate, must be hydrogen carbonate. Meaning must be something like this. You must see this HCO3 thing. Then only is endothermic reaction. And then another one is thermal decomposition. A lot of people, they thought thermal decomposition, I'm supplying heat to the reactant, it should be exothermic. No. It's just like evaporation and boiling. They are endothermic reaction. Because overall, you can see the particles is absorbing more heat compared to what they release. During the process, you are supplying the heat. Okay? So thermal decomposition, same thing. What do you mean by thermal decomposition? You are using the heat to decompose the reactant. For example, if I heat a carbonate, what will produce? You learn this in salt chapter, okay? I give you an example first, which is magnesium carbonate. When you heat them, they'll give you magnesium oxide, carbon dioxide. A very popular question, magnesium nitrate. When you heat them, they will produce magnesium oxide, nitrogen dioxide. I haven't balanced the equation yet, Hold on, this is 2. This is 2 and 4. Okay, last one is electrolysis. Okay, what about acid plus hydrogen bicarbonate or hydrogen carbonate? Endothermic reaction. Acid plus alkaline, exo. Okay, understand? Dissolving ammonium salt, there are 8 only, you see. 8. Electrolysis, melting, evaporation, or boiling, photosynthesis, dissolving ammonium salt, dissolving crystallized salt, or hydrated salt, reaction with acid and bicarbonate, last one, thermal decomposition. Correct? So I can memorize, so do you. Is it the endothermic reaction? Temperature increases. Is this an endothermic reaction? It's not, right? So this is out. So is this neutralization? Zinc oxide. What is neutralization again? Give you salt and water, correct? This is base. So C, neutralization is actually reaction between acid and alkaline, and base also that. As long as your product is a salt and water, that's neutralization process actually. You know what I mean? What's the difference between base and alkaline? No. What's the difference between them? They are actually the same family, but what's the difference between them? Base are solid. I mean, base are everything that can react, that can neutralize acid. Alkaline is a type of base that can dissolve in water. Meaning you put in water, you stir it, it's gone, becomes solution. So alkaline means base that are soluble in water. That's one. Okay, neutralization is a reaction that can produce salt and water.